Okay, this review, we're doing a hypothesis test. We sample 200 males, we sample 200 females. We find 45% of the males buy clothing online, 71% of the females. So, is there evidence a higher percentage of females buy clothes online? So I started out, I went, the proportion of males equals the proportion of females. Now I'm going to define PM is the proportion of males who buy clothes online. If you don't define it as a proportion, you're not defining it correctly. So I have a lot of students who, in the end, in their decision, they talk about it being like the number of males. If you do that, that's wrong. In the decision, it might be that the number of males is less than the number of females, or the number of females is more. That's not a correct decision. You have to talk about proportions and whether they're greater or not. So we are talking about those things called proportions, which is out of 1, it's like a percentage, but we understand like 0.45 is the equivalent of 45%. Okay, so now what is PF? PF, ditto for the females. So it's the proportion of females that buy clothes online. Now, since I put the males first, my alternative is that the proportion of males is less than the proportion of females. If you put females first in the top one, that's fine. But you're saying that the females are greater than, and here's all that's going to affect. I'm going to have a negative z-score. You're going to have a positive z-score. I'm going to have the same exact p-value as you because the curve is symmetrical. So that p-value won't change, and the decision will be the same. You're going to figure out that, according to this, the females have a higher proportion that buy things online. So now our assumptions and conditions. This gets you 2 points if you write it this simply. We randomly sampled the groups, but groups plural. I saw it on the quiz where people put group. You missed a point. It's not a group. It's not one. They took the males, they randomly sampled the males. They took the females, they randomly sampled. We're assuming also the males don't affect each other, the females don't affect each other, the males don't affect the females don't affect the males. That's the independence. So if I wrote this out more formally, I would say we randomly sampled both groups, and there is independence within and between the two groups. But that gets you 2 of the points. The last point is a little more difficult. We're going to have to multiply, so you grab your calculator, and you multiply, you're going to have to take 200 times 45% or 4.45. You're going to find 90 males bought stuff online. That's bigger than 10. Then you can subtract, and there's 110 males that buy stuff online. That's bigger than 10. We multiply the females, and we get 142 is bigger than 10, and 58 is bigger than 10. So that makes this nearly normal. It's important it has to be nearly normal. If we don't have a normal curve, then the z-score is pretty meaningless in terms of coming up with that p-value or that percent. Okay, so hopefully you see the 3 points there. These are 2 of them. This one is the last point. That's 3 points. Hopefully we saw the 3 clear points up here. All right, so next, we're going to run a test. Make sure in your test, however you put it, raise of hand, anybody put females first? Okay, you make sure you put females first in your calculator if you didn't already. So then we go menu 6, 7, and 6. The 2 proportion z-test. I have, 45 males? No, 90 males out of 200 after I multiplied, and 142 females out of 200. And I'm putting less than, you're putting greater than if you put females first, and that's fine. Just make sure it stays the same. Don't start flipping stuff around and go, this is females equals males, and then males is, don't flip them around. Keep them the same for consistency. Okay, so this z-score is quite far away. The next 3 points are pretty simple, pretty basic. 2-prop z-test. We could do a formula. I'm not going to take time with the formula right now. The z-score is 5.26. If you're 5 or negative, was mine negative?
Yeah, negative.
Okay. if you're 5 standard deviations below the mean, if you were to draw that out and you go 1, 2, 3, 4, 5, and then a little bit more, that's quite far away. That's what we call significant. It's statistically significant. And the area here is going to be very small. And in fact, the p-value, be careful of this because I've had students already on quizzes. Regardless, they're always making this mistake. You notice here it says E-8 at the end of that. That's not 6.91%. That's 0.00007 zeros, and then the 6 comes in. So this is very, very small. I always say if you get E-4, you can just kind of say that's approximately 0. Got to put it in the correct spot. So my p-value, come on, my p-value is roughly 0. Now, 0 is less than 5%. Hopefully we've got this down now. I've done one on purpose of each kind. We are going to reject the null. We don't think the null is therefore true. If we go back up here, we're saying, all right, they're not equal. We think that the males are less than the females. So down here we say, therefore, now don't cross that off on your test. You won't get credit for things that are crossed off. I do that for effect so we understand our decision. We believe the proportion of females is bigger than the proportion of males that buy stuff online. Okay. Now, what if I said the proportion of males is less than the proportion of females like I said up there? That's the same thing. It's semantics. Those two things, they are totally the same, mean absolutely the same. Okay. Any questions? When we reject the null, it's because the p-value was less than 5%. It's small. We still talked about the alternative in this problem. Now, I don't have this on there. If we've made an error, what's the only error we could have made? We rejected the null. Type 1. We threw out the first hypothesis. So the only error we could be making is throwing out the first hypothesis, because right now we're accepting the second hypothesis. Okay? So we could only make a type 1 error here. We cannot make a type 2 error in this case when you reject the null. Type 1 is reject the null when it was actually true. So, and it's very unlikely because this happens almost never, like a 1 in 10 million chance or something like that if we figured out 7 in 10 million. All right, now the next one, question 2. This is over multiple chapters, so this one is a 1 proportion test. We are flipping a coin. We flip it 37 times. It comes up 22 times tails. Is there evidence that it's not a fair coin? A fair coin would have a proportion that equals 0.5. Now, hopefully you notice the difference. The last one, we had 2 proportions. We didn't have an exact number we're comparing it to. Here we do, and it has to come from that idea of it being fair. So then the alternative, P is not 0.5. P is the proportion of tails on the coin. Random, independent. Now notice the difference. I'm not lumping that together. I'm not focused on there being groups. That is different than this. I had students, and maybe it was even student, maybe it was one person in here, I don't know, but if it was you, who said this ran in on this question on the quiz. Both points are wrong. Okay, because you don't have random groups and you don't have independent groups. That word groups needs to be in there in order for that little shortcut to work. Here, I flipped the coin, it's random. Okay. One flip doesn't affect the next. Okay. But now we have 22 successes times it came up tails. We have 15 times it came up heads. That's the failure in this case. Because those are both bigger than 10, we have a nearly normal curve. So then we can calculate z-scores. One problem, z-test. We need a z-score, we need a p-value. Menu, 6, 7, 5. 50% is our null, 22 out of 37. And we're going not equal to. Everybody got it? Anybody need me to slow down? We get 1.15 and about 25%. Now I want to show you something. If I go a normal CDF from 1.15 on up. Oops, I guess I need the 0 and the 1. Maybe not. Must be forgetting something. 1.15 to, what did I type wrong? Oh, it's just norm CDF. That gets me 12.5%. Okay? The p-value seems wrong.
You have it on both sides of the curve.
I do. There we go. So this 1.25 makes this 12.5. It would also shade that, so it doubled it. But the calculator already did that. If you slide this up a little bit, it already took that 12.5 times 2 and got roughly 25. Of course, I'm rounding a little bit. Okay. So you don't have to do anything like that. Because you put not equal, it did it for you. .16 if we round, 25. 25 now is way bigger than 5%. So our decision is different. We fail to reject the null. What does that mean? That means we're keeping the null. And we're in essence rejecting the second one, but we don't talk like that. It's the idea of guilty, not guilty. We're saying they're innocent, but we don't say innocent. And why not? We didn't prove it's 50%. We flipped the coin, and when we flipped the coin, it was a standard deviation above the mean, plus a little bit. It actually came up 59% tails. That doesn't prove it's 50. 59% tails and 40% heads doesn't prove it's 50. So that's why we say not enough evidence to say it's unfair. But we always talk about the alternative. So I don't cross stuff off. If I fail to reject the null, not evidence of an unfair coin. Now, there's different ways I could have said that. It's not evidence that P does not equal 0.5. But again, it doesn't prove it is 50%. Why? I got 60%. How does 60% prove it's 50? It needs to be 50 to prove it's 50. Now, the only error we could be making is what? Type 2. It's the one we crossed off because we were, in essence, we failed to reject, so we stayed here. We rejected this one. Okay? Now, I could ask you to define a type 1 error. A type 1 error would be rejecting that it is equal to 50%, saying it's not, when it really is equal to 50%. Okay? But the only error I could be making here is a type 2. In any problem, I can ask you to define a type 1 and type 2 error. Okay, number 3. Now, in 3, again, sample males and females. Again, this data, I got this data online. 100 men find that 47 have bought technology online. A random sample of 100 women, 33 have bought technology online. Create a 90% confidence interval for the proportion of men that have bought technology online. This is 6 points. The first 3, I'm going to divide it like this. Random, independent, 47 is bigger than 10. 53 is bigger than 10. So it's nearly normal.
So we don't need a 10% check for these.
You can say 100 is less than 10% of all men. That goes with the independents.
I did it just around my bases to make sure.
Yep, that's okay. That one won't cost you. If you forgot independence, it would get you that one. Okay? Now, why didn't I say independent groups? There are groups. There's two. I'm only talking about the men in this problem. So I'm going to do the men as one thing here. Next, one proportion Z interval. Now the one proportion Z interval, I didn't do the formulas for the hypothesis test, but P hat plus or minus Z star times P hat Q hat over N under the square root sign. If you do that, why would you do that? Put a little DG by it, don't grade. Means you want me to count the first part, because that gets you credit for it. The only reason you would do that, and maybe you want to fill in the numbers, is so you're practicing it for the AP test so that you know it more for a multiple choice question. If you don't want to do that, that's okay. All right? But we're going to run this interval. Menu 665. We have 47 out of 100. We're doing a 90% confidence. And it gets us 0.387 to 0.552. Now pay attention to my wording that I'm going to do here. I am 90% confident the true proportion of men who bought tech online is between, now since I said the true proportion, I should use proportions. Proportion is a value in between 1, so I'm going to use 0.388 to 0.552. I think. I could write the true percentage, and then I could make that 38.8 to 52 or 55.2. Okay, now part B asked me to do this for the women. Fair enough, 6 points. There's no hypotheses. Why? We're not being asked to test anything. We're creating an interval. We're not even being asked to answer a question. I could ask a question and say, is it possible that 50% of the men had bought tech online? Is that possible? Yeah, it's in the interval. Is it possible that 70% have bought tech online? No, it's not in the interval. It's not a possibility. Okay, so now in part B, we're going to do this for the women. So we're going to go random check, independent check. The women at 33 and 67. Those are both bigger than 10. So nearly normal. We're going to do a one prop Z interval. I'm not going to do the formula this time. Hopefully you get that idea, you know, if you have that. But I'm going to start writing the sentence for the women. I am 90. Now, if you want, if somehow this is below the other one on a test question, and you ditto this out, ditto for the women from up here. The only thing that's different are going to be the numbers, right? Okay. So we got to put those numbers in. We got to do it 33. $252 to $407 or $253 to $407. Good. Now part C says, could they be the same? Okay. Let's say that the real deal for women is 39%. Is that possible?
Yeah.
Could the men be 39%? And don't say just barely. Could it be?
Yes.
Yeah, it's in there. Possibility. So what we're looking at is there's overlap. It's not much, but there's overlap. They could both be 40, right? Has nothing to do with oh, you just barely made it. Sure, the number just is in there, just on the edge, but that it could be they're both 40. So the answer to part C is simply yes, they could be equal. The intervals overlap. Plain and simple. You're going to see one like this tomorrow on the review as well. So now part D. It says create an interval for the difference. What's the interval for the difference? The interval for the difference takes p hat 1 minus p hat 2 plus or minus z star times p hat 1, q hat 1, or n1 plus p hat 2, q hat 2, or n2. But it really subtracts these. Let's remember the men was estimated at 47. The women was estimated at 33. That's a difference of 14. We're going to take the men, subtract the women, since the men was listed first. Excuse me. So, assumptions. Now we make it clear there were two groups. Why? We're doing a two-group confidence interval. So hopefully you see the difference in that. We had 47 successes in the man, 53 failures. We had 33 successes in the women, 67 failures. I don't need this formula. If you put that formula, you get credit for the next thing I'm going to put down. The next thing I'm going to put down is 2 prop z interval. But what it finds, it subtracts the difference to build it. So we're going to see this after I put it in, and I'm going to point something out on the calculator screen so that you remember when you define this one to put it down. Menu, statistics, confidence interval, 2 prop z interval. Still 90. We're staying consistent. We're doing the same level of confidence every time so that we have comparable things here. But notice one thing it says here is P diff. Okay? It took, for the males, it took the 47 minus the 33, and it got the difference of 14. And that's how it built this interval. The males are 14% in the sample higher. Now we've got these two numbers. So when you write this, I want you to remember you got to be talking about the proportional difference in these. So I am 90% confident the true difference in proportions. And then the way I usually do it is I go, we took males minus females. I give the order. But it's the difference in proportions. We're subtracting those. The true difference in proportions for buying tech online is between 0.027 and 0.25. It's between 3% and 25. Now that whole interval is positive. Why is that important? Took males minus females, and the only options are it's 3% to 25% higher for who? Males. Now we had just come up with in part C when we compared the two, they could be equal. we're going to talk about this, but this one tells us. Now, I should have added a couple questions, so I'm going to add some talking points here. What this would tell us is the males definitely have a higher percent of buying tech online. Okay? It's 3 to 25% higher for the males. Conclusive, according to this. The last question we'll address now, which one is the real answer? Which one should we do? Should we do the two different ones, or should we do this one? And boy, I get all sorts of crazy questions. It's like people fall asleep on me on this, okay, on the test. But I always ask one like this. But this concludes that the males are higher. Before, when we look back at part C, we said they could be the same. It's not conclusive, okay? So what's the correct thing? What's the better one to use? In part E, should you use the two separate one proportion intervals or the one combined? And the answer is you use the two prop Z interval is better. We say it's more robust is what the word usually is, but it's better due to combining samples. Really, it's like you have an overall bigger sample, and that's more reliable. We sampled 100 here, 100 there. We're going to combine those groups, and that's going to be a better answer. So the conclusion, if I had a conclusion on it here, would be that it appears males buy a higher proportion online. Well, a higher proportion of tech things online, whatever that is. Could be smartphones, could be computers, whatever. We concluded in the other one that females buy clothes more online. Yep, I'm gonna get it.